When studying angles in a polygon, we're moving more from the vocabulary of naming parts or classifying into solving problems, like trying to find the missing pieces in a puzzle. The triangle sum of interior angles. This means that the sum of the measures of the angles in a triangle equals 180 degrees. So we have a triangle here. The measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 has to equal 180 degrees. There's two ways that this fact is used. One, it is use it to find the missing angle measure. If they had told you measures of angle 1 and angle 2, you could add those together and then subtract that from 180 to find the measure of angle 3. This is also useful in proving if a figure truly is a triangle. You could be given 3 angle measures, and using this fact, the sum of interior angles, deciding if those 3 angles could be pieced together to make a triangle. A diagonal is a way that we find the sum of interior angles of other polygons. It is the line segment that connects two non-adjacent vertices of a polygon. So from a previous lesson, we know adjacent means side by side. So the purple outline is the quadrilateral that I had drawn, and the red is the diagonal that goes across. I pick a vertice and I connect that to other non-adjacent vertices. This one is adjacent to it, so that doesn't work. If I were to connect those, I'm simply just drawing over the original quadrilateral. The same thing down here, so I'm connecting it across here. And what that diagonal does is it separates a polygon into triangles. And then we can use what we know about the sum of interior angles of a triangle to find the sum of interior angles of any other polygon. So since the sum of interior angles in a triangle is equal to 180 degrees, a 4-sided figure, a quadrilateral, is 2 times 180 degrees because it's been split up into 2 triangles. So that brings us to the quadrilateral sum of interior angles. The sum of the measures in a quadrilateral is 360 degrees. Like I said before, take the time to draw this figure. Draw the angle measures, otherwise your notes are not going to make much sense. So pause the video if you need to do that to make sure you have all of these figures copied down in your notes. If you were to find the unknown angle measure in the quadrilateral, you're going to take the measures that are given to you, add that to x. So set that up into an equation. X plus 98 plus 137 plus 52. I know that's going to equal 360 degrees because of our last slide. Add the 3 angle measures that I know. So in expressions equations, we call this combining like terms. I combine my constants. Those 3 add to 287. And it reads the equation x plus 287 equals 360 degrees. I'm going to undo adding 287 by subtracting 287 on both sides. So the missing angle measure is 73 degrees. And I know that makes sense because I can tell that is an acute angle. It's less than 90 degrees. I can draw triangles to find the sum of interior angles in any polygon. So I started with, let's see, that is a 1, 2, 3, 4, 5, 6. So I have a hexagon here. And I just picked a vertice right here. And I did dotted lines connecting that vertice to other non-adjacent vertices. After I did that, I saw that I had 4 triangles. 1, 2, 3, 4. I can take 4, multiply that times 180 degrees because I know that every triangle has a sum of interior angles of 180 degrees, and it equals 720 degrees. So I can say that this hexagon has a sum of interior angles of 720 degrees. If you think about the other figures that we've looked at, a quadrilateral had 4 triangles. A triangle has 1 triangle. So the number of triangles is always going to be 2 less than the number of sides. So if you saw something crazy like how many triangles are in a 23-agon, that means a 23-sided figure. Well, there would be 21 triangles. No need to try to draw a 23-sided figure and split all that up. You can take the number of sides, subtract 2, and that tells you how many triangles. And then from that, you can find the sum of interior angles. Go ahead and pause and practice these problems, and again, draw these figures in your notes. On practice A, out of the given angle measures of 43 and 60 plus x, I know that's going to equal 180 because that's a triangle. 43 and 60 add to be 103, so I have the equation 103 plus x equals 180. Undo adding by subtracting 103 on both sides. X equals 77 degrees. Then come over here to B. I have a quadrilateral. The squares in the corner tell me that those are 90-degree angles. So 90 plus 127 plus x equals 360. Kind of ran out of room right there. When you add 90 and 90, you get 180. So in my head, I said, well, 180 plus 120 is 300, and then I have 7 left over. So 307 plus x equals 360. Subtract 307 on both sides, you get x equals 53 degrees. On part C, the directions say to divide each polygon into triangles to find the sum of its angle measures. This is an octagon, so you could have done the shortcut, counted the sides, so there's 8 sides. 8 minus 2 is 6, so there's 6 triangles, and then went from there. But I went ahead and connected the vertices of non-adjacent angles, and then I ended up with 1, 2, 3, 4, 5, 6 triangles, 6 times 180. And trying to do that in my head, you can kind of see where I jotted some thoughts down. 6 times 100 is 600. 6 times 80 is 480. 600 plus 480 is 1080 degrees.